Hello, my name is Rob Reynolds. Welcome to Business Calculus, Chapter 6, Section 2. Just a quick little note, as you're doing your homework, it'll say Section 3 because that's from your book, from the 10th edition, but an earlier edition, the 8th edition book, which I don't think you're using, it says Section 6.2. So either way, it's integration table. So we're not going to be using substitution to integrate. We're not going to be using integration by parts like we learned in 6.1. Instead, we're just going to use a bunch of formulas that we're going to look up in a chart. So again, when you see section 6.2, click on that link, but it's in your textbook. It's actually 6.3 if you're following along. And either I'll give you the formula or there'll be a link for you to choose. And when you open up that link, it'll open up some integration tables, but I posted some integration tables online, and I would encourage you to look at those online and even print those off. So to integration tables, we're going to look at reduction formulas. These are too difficult to memorize, so obviously I'll provide a cheat sheet or a link to these tables. This is also found in your book in Appendix C. If you're interested. So again, some examples are Formula 17, Formula 39, if this is what the format that you're trying to. So you're going to be looking at something and trying to pick a formula that's close to it in terms of U, A's, and B's. Again, here's all the formulas that are provided. There's quite a few, but they're organized really well. See, the whole set here is kind of in this square root of u squared plus or minus a squared, and I'll explain. U is the variable, a is the constant where it's a number. And so you go through these tables and you kind of find something that's close. I don't think we're going to do a whole lot with tangent or secant, but you might run across a trig function. So let's try the first example. We need to find, using our integration tables, something close to this form. So it's been my experience that if you continue using the same integration tables, you'll start remembering where these formulas or the general formulas are at. So I would keep using the exact same formula cheat sheet the whole time, and my recommendation would be to use the one that I've posted on Blackboard. So you scroll through here and you start looking for something that's in that form of x over the square root of x minus 1. And eventually you'll get to something that looks like this in number 19. So I'll come back and I'll paste number 19 here so you can see how this formula is going to work. So now I can see this is close to this, but instead of it's close, but I have to do a little bit of a rewrite. So I'm going to do the square root of that u is the variable, which is the x, over, and my a term is actually this negative 1. So we could rewrite this problem to be the negative 1 plus the square, plus negative 1 plus x, and then that radical all here. So now this looks a lot like our original problem. So I'm rewriting the original problem to be x over the square root of negative 1 plus x, just because it fits my formula a little bit better. So sometimes you have to manipulate these formulas. Once you do that, then I would start identifying who the a term is, who the b term is, and who my u term is. So in this case, a is negative 1, b is 1, and u is x. And I think I can highlight that b is 1, the u term is that x, and we already found a, right? That this term right here. All right. So hopefully that makes sense. But once you have the formula, it becomes pretty easy. All you do is you rewrite exactly the answer, and you just plug in for a, b's, and c's. So negative 2 minus x, all divided by 3 times 1 squared, the square root of x minus, really it's negative 1 plus x, but we can write it back in this form, and I am done. So again, using formula 19, identify the a, b, and x. Oh, so this was the simplified version. So, so from here we can factor out a negative 1 and make this what? X plus 2. And then this negative 1 will cancel with this negative 1. And that's how to get to this positive I like that. So then they brought this 2/3 out front. I don't know if my math lab will require you to do that, but if it's multiple choice, you'll have to find it. This next one, I would, again, just use my integration tables and try to hunt for something that's in the form x times the square root of x to the 4th and something's close. I don't, so I'm looking in here, and this is close, but I don't see, it doesn't have an x out front. So look at number 23. It's close because it says the square root of two things that are squared, and that's what we have. We've got two things that are being squared, so I can see this is the x squared minus the 3 squared, but we don't have that x out front in the formula. So sometimes we can do a u substitution, which I told you that we didn't need to do, but in order to fit the formula, maybe we could do a quick let u be the x squared, so then the derivative here is 2x dx. And of course, you're going to divide through by 2, so it would fit. So now this x dx is my 1/2 du. I'll pop out the 1/2. I'll integrate the square root of the u squared minus 3 squared, which is in this form we talked about, du. Now I can use formula number 23. So I'll snip that and bring that into my slides and see if I can't identify the a, b, and c terms. So here we go. It's 1/2. The u, well, is right here, is my x squared term. And then I'm going to do x squared squared, so that's x to the 4th, minus the a term. Here's my a. A equals the 3. So 3 squared is the 9, minus, now it could be plus, it could be minus, but remember whatever that is, and that is. So I will continue using the minus sign, and then I'll go back to the a squared term, which is 9, the natural log of the absolute value of my u term, which is x squared, plus the square root of the same thing I did before, x to the 4th minus 9, and close the absolute value, close the parentheses, plus c. Again, it's written out a little bit nicer. These answers are posted on Blackboard if you haven't already. Look there. So we're going to continue using our integration tables and try to find something that looks like 1 over x times the square root of x plus 1. And I think I see something in this area, maybe 15. So I'll copy and paste 15. Oh, that's 23. Let's not do 23. Okay, there's my 15, and it looks pretty similar. So again, I'll start identifying. It looks like the a term might be 1, the b term might be 1, and u equals x. And so I will start writing this answer, which is 1 over the square root of a. I'll write it square root of 1. The natural log of, good thing I don't have to memorize this, the square root of, so this is going to be 1 plus x in here because the a term is 1, and my u term I've written as 1, but it's x. I'm so sorry. But instead of writing 1 plus x, I just think it looks nicer as x plus 1, so using the community property, minus the square root of 1 all over. Same thing, but change the sign from a minus to a plus. Oops, that's not it. It's this plus 1. And again, I'll do that x plus 1 plus c. So once you find the formula, again, pretty nice. Here's the author's explanation. It looks like they got the same thing. The hard part is, again, using those integration tables to find something that fits. So you try. Example number 4. Hunt through the integration table. If you haven't already, it starts out with differentiation, and it's organized pretty well. It looks like these are It starts out with your a plus bu terms, then it's that square root, and in example number 4 I didn't see any square roots, so I'll just keep hunting down. These 21 and 22, there's no square roots, but things are being squared, and in example number 4 I need an e, it looks like, or maybe I need a power. So I'm going to keep going because I don't see anything. Aha! Now I get down to something around the 30 areas and 40 areas. Sorry, I don't really know why that keeps happening. But when I let go, that's something bad. But can you see the 36, 37, 38? So formulas using e to the u. And it looks like I've got an e to the negative x squared. So it looks like 39 is going to be a good match. So I'll bring this in. And this looks like something I want to use. So let's try to identify. It looks like I want u to be this x squared term, or negative x squared term. Let's try it. Let's let u equal negative x squared. And if I do that, then du is negative 2x dx. And I don't have a negative 2, so I'll divide that out. So I'm going to let this x dx be my du and my substitution. So I'm really integrating 1 over 1 plus e to the u. Oh, yeah. So that's, because remember this x up top is part of my du. So when I write this du, that x is in that du. So integrating this using this formula says I'm going to write down, well, remember I have this negative 1/2 hanging out front, so I better keep that. So negative 1/2 just kind of stays out front. And then my u term is negative x squared minus the ln of 1 plus e to the u, which is negative x squared, plus c. So this one isn't really plus c, it's because it's not an indefinite integral. We have a definite integral between 0 and 2, and oh my goodness, so you're going to have to do the fundamental theorem of calculus, f of 2 minus f of 0, and I would definitely recommend using a calculator for that, and probably just going going for a decimal. I don't think anybody, let's see what the author did here. I don't think anybody wants you to find the exact answer of that. Now this is interesting because this is negative and this is negative. You could factor out a negative 1 from this. Oops, so sorry. That's really strange when my computer does stuff like that. And then that's what makes this guy. So this negative 1 gets multiplied by this negative. Cleans it up a little bit before you evaluate it. So try using your calculators and see if you don't get the 1.66. But there's the work for it, and here's a visual representation. The last two examples have to do with reduction formulas. In fact, I think example number 5 and number 6, it's the exact same problem. Number 5 is just asking what it is, and then number 6 asks what the answer is. This is an indefinite integral, and then example number 6 is the definite integral using an application. So a reduction formula means I'm going to have some reoccurrence relationship here. So I'm going to see something kind of repeat here a little bit. Again, I'm going to use my tables, and I will hunt once again for something in the form of x squared e to the x. It looks like I can use these formulas in here, or one or two of them, because these formulas look like, well, especially not 36 because I don't have the x squared, but maybe something like 37 or 38. And because u is being squared, I'll probably use 38 first. I might have to, again, repeat something. So and then go back and use another formula, which you haven't seen yet. So I'm going to do a little let u equal x. And in the formula I have an n, and it looks like n is 2. So using the reduction formula, I'll try to write this statement in the form of, remember, if u is x, then du is dx. This turns out pretty nice. So I'll start writing this guy. So the u is the x. The n exponent is a 2. E to the x minus 2. And then I've got to integrate. So here comes the recurrence. X e to the x dx. And so now I think I need to try to integrate this. And this looks something like 37. So I'm going to use my integration tables twice. So I'll keep this x squared e to the x minus 2, and then using 37's formula, I'll write this. So it's times the quantity of x minus 1 e to the x, because that's the u term, plus c. And then maybe I'll just clean this up a little bit. I bet my math lab would have taken that, but I'll just distribute this -2 throughout. Plus 2, well, and the e to the x. Ooh, let's see, this is an e to the x in here. Plus c. Oh, I can even, now everything has an e to the, why don't we just factor out an e to the x then? So I've got x squared minus 2x. We like things in factored form because it cleans things up and it's easier to find roots. That way, let's see what the author did. So good, using 38, then using 37, and then do a quick, hey, good, they did a quick little rewrite as well. So there's the final answer for example number 5. We can always do a check. I'm taking the derivative of that thing. And then the application would be, hey, here's a story problem. Can we integrate this thing from A to B? And it looks like the A term is 0 and the B term is 0.875. So we go ahead and just use the exact same formula that we did before. We already have the answer to most of it. All I have to do is pop this guy out. This is just a constant. E is not a variable. E is that 2.71828 number. So I'll just pop that out, and then it's the exact same problem as I had before in factored form, and then evaluate that between 0 and 0.875. Use your calculator and see if you don't get the 0.608. Of course, you could always just type in the original problem using Math 9. If you haven't practiced that, I would encourage you, and see if you just don't get the same answer. But again, the point of this is to use those integration tables because Math 9 will only do the definite integral. It will not do the indefinite integral. I hope you found this video helpful. If you have questions, please email me.